It's best to think of pseudostratified columnar epithelium as a specialized variant of simple columnar epithelium. There are several types of cells whose nuclei lie at different heights in the epithelium, but every cell has a basal process that attaches to the underlying basement membrane. Hence, every cell can directly participate in metabolic exchange with nearby capillaries and be regulated by the basal lamina. However, not every cell reaches the surface. In particular, basal cells don't. Look carefully at this image from the epididymis. The epididymis is an organ that lies alongside the testis. Sperm enter the epididymis from the testis, and there they are stored and finish their maturation. The epididymis has two sets of ducts, both lined by pseudostratified columnar epithelium. This image is a large cross-section through the duct of the epididymis. This duct is very long and coiled, so that sectioned many times. Look at the epithelium of this section of the duct. The main cells are tall columnar. In addition, small basal cells are crowded next to the basement membrane. Their round nuclei lie distinctly below the elongated nuclei of the columnar cells in the epithelium. So this epithelium is pseudostratified. The basal cells are predominantly stem cells that can divide and differentiate into functional columnar cells as they get worn out and die. The columnar cells have a very obvious brush border, even longer than you saw on the enterocytes in the duodenum. These are microvilli that are so long they've been given the special name Stereocilia. It's a poor term left over from before the advent of the electron microscope. These structures have no relationship to cilia, and their function is to absorb water very quickly. In case you're wondering what the small dark dots and masses in the centre of the duct are, they're masses of sperm, which are maturing while they're in storage. The smaller efferent ducts of the epididymis are also composed of pseudostratified epithelium. The two main cell types are tall ciliated cells and shorter non-ciliated secretory cells. The two cell types tend to cluster with their own kind, so the epithelium varies in height around the tubule. And this makes the lumen a star shape, in contrast to the basement membrane, this thin pink line here, which presents itself as a nice smooth curve. This is a section taken from the lining of the nasal cavity. The epithelium is pseudostratified columnar with cilia and mucous cells. The name pseudostratified is questionable here because the cells are so jumbled that you could have trouble knowing that it was not truly stratified. All the cells do indeed touch the basement membrane, as has been confirmed using electron microscopy. However, many of the tall cells will only have a very thin, narrow connection to the base. In an epithelium like this, the boundaries between the cells are pretty well invisible. This epithelium contains half a dozen or so different cell types. You should be able to distinguish three: basal cells, cells with cilia on their apical surface, and the goblet cells, which you've already seen in a previous section. Ciliated cells and goblet cells accompany each other throughout the respiratory tract. Each goblet cell produces a layer of mucus on the surface of the epithelium to trap dust particles and bacteria. The ciliated cell then moves that layer across the epithelium. As mentioned earlier, the nuclei of goblet cells are usually compressed basally by the massive mucus stored in the apex. The ciliated cells have a tall eosinophilic body which flares out near the surface of the epithelium, so that its cilia cover most of the surface of the epithelium. Oh, just before I move on, I've just spotted something in this image that may confuse you. Don't be fooled by the view of this goblet cell here, appearing to be also ciliated. This is due to the deep focal plane of the section image, and so you're seeing cilia from a columnar epithelial cell deeper in the plane of section to the goblet cell.